Hello guys, hello everybody. Welcome to Olga channel. This is Cindy, and then today I'm going to talk on the interpretation of um, linear programming solutions. So the other time we looked at how to solve linear programming using Excel. We are using the same problem or the same solution, and when it comes to interpret it, the interpretation is not that difficult, but you need to be attentive. Okay, so let's start from this side. So this is what we have. You will have, or this is the sensitivity analysis that you have after Excel has solved it for you, and we have it here. So this is what you have after Excel solving it for you. Okay, so what does all these mean? So first of all, I'll use this part to explain, then I'll go back to Excel. Sorry, I'm not that well, but I'll manage. Okay, so this aspect refers to the variable side, right? So this is the variable side and this is the constraint side. As we can see from Excel, the variable side and then the constraint side. So this part is the decision variables. That's the name of the decision variables. This one is in regard to the quantity to be produced or to gain, to have of the decision variable. So quantity for each decision variable that will help us to either maximize or minimize our objective function. This reduced costs refer to the opportunity costs for these quantities. So the zero means it has no opportunity cost. This ones also have no opportunity cost, but this one has an opportunity cost of 5. That means in order to gain in order to gain a value for this product, that's sandals A on production line, on the old production line, then we need to forego something. You get it? So the reduced cost means you have to reduce the objective function or the objective coefficient for this product by 5. And when you reduce it, that is the only way it will have access towards a quantity that is greater than 0. So if its opportunity cost is still 5, it will be 0. But then if you forego some of the costs, right, it will give this one access to some of the quantities from either this or this. So that's the 5. That's opportunity costs of for foregoing some of the products in order to produce the sandals A on the old production line. So that's the 5. That's the opportunity cost. And the coefficient, that's the objective coefficient, is the contribution of each of these variables to the objective function value. So we can see all these from the question. And if you want to see more of the question, please visit the other video. So this is how the question looks like. But we'll not be going to the question today. We are on interpretation. All right. So this allowable increase and then allowable decrease, I'll explain that on Excel. So what this allowable increase and allowable decrease is telling us is that, so Excel has solved for us. We told Excel we want what? The minimum value, right? So minimum values that will give us minimum objective function. So this question is talking about total cost. So with cost, we all know we want to minimize cost, right? All right. So Excel is telling us that maybe you're a business personnel, you're solving a problem, but then you might not find my solution feasible. You might want to produce sandals A on the old production line, but I'm saying you don't produce. But then I'll give you some allowances, right? Just like going to sew a dress and then the allowances, so that in case you feel like you want to expand the dress, you can do so on your own without having to destroy the dress. Okay. So Excel is also telling you that I've given you some allowances. So for the first one, I've given you an allowable increase of 5 and allowable decrease of 45, which pertains to the objective function or the objective coefficient, not to the final value. So this final value is the quantity you are producing for each of these products, right? And then these are the objective and their contribution to the total cost each. And then this allowable increase and decrease pertains to the objective coefficient. So it's telling us that, okay, so I can give you a particular range by which you can increase or decrease the objective function of the objective coefficient you gave me. Maybe you might change your mind, you don't want it to be 30 anymore, you want to change it, but then these are the allowances I'm giving you. You can increase it by 5 or from 1 to 5, or you can increase it for decrease it, okay, by negative 40, sorry, decrease it by 45, right? So that's what Excel is giving you. So you have to know the range that you have. So this is the range. When you subtract 45 from 35, you get negative 15. When you add 5 to 30, you get 35. So this is the range within which you can what? Increase or decrease the objective function. Anything below or above or on the boundary, you are going to have an effect. So every decision you take has an effect. But if you give or if you allow the objective function to be within this range, then the final value will not change, right? The final value will not change. It's only the objective function value that will change. So what I'm saying is this. So let's come here. So here we have 50,000, 0, 30,000, and 40,000, and we are on this one. So I'm trying to say that they've given you an allowable increase of 5 and decrease of 45. So it means your range is within negative 15 and then 35. So if you increase within that range, you can produce the same quantity. So let's take 34. If I make here 34, then you go to solver. Okay, so when you change it to 34, don't leave it like that. Go to solver, which is under data. And then I showed how to install the solver the other time. So you can check my video named what linear program solving for linear programming. So we are solving this one. So you realize that when we change it to 34, when we change it to 34, the value did not change. It was still 50,000, right? But then it was the objective function value that changed from 380 whatever to 400 and something whatever. You get it? So if you change it within the range, it is not going to affect the final value, but it's going to affect the objective function value. So let's take, for instance, we don't want 34, 135, which is exactly on that range, and let's see what will happen. So if, let's say we are taking 35 and then we'll solve. So what happened? So when we changed it to 35, realize that the final value, that's the quantity to produce, change to 1,000, and the objective function also changed, right? So this is telling us that if we want to produce the same quantity but want to reduce the cost, then it should be within the range given by the allowable increase or decrease to do so. Else anything on the range or outside the ranges, then you are going to get a change in the final value. So you can do an experiment on your own for the rest. You can do it for this. Look for the range and try it on your own and see. So now with the reduced cost for 0, I was like, it was opportunity cost to forego some of the objective function value, not to give that product access to what a quantity greater than 0. So this is 5, right? So let's change this 50. Let's subtract 5 from 50 and see what we get. We get 45, right? So let's make here 45 and see what will happen. Then we'll go to solver. Then we'll solve. So you see, when we change it to 40, we got what? 40,000. But when it was 50, it was 0, right? So this had a reduced cost of 5, telling us that foregoing some of this coefficient objective coefficient is going to give it access to final value that is valuable, that is greater than 0. So that is what the reduced cost is all about. Okay, so don't be confused. Then what else? So we are done with the variable source. So you can be doing changes on your own to understand better because it's not difficult. Then the constraint aspect. So this side, the final value here is not the same as this side. So since this is constraint and yet everything right hand side, this side is the left hand side, which we saw here. This one, left hand side. So what this constraint is telling us that. So first thing we have to know is the constraint binding or not binding? Talk about binding constraints. We're talking about the fact that the left hand side is equal to the right hand. That is the resources. So the right hand side is the resources that has been fully utilized. So if the left hand side, which is this final value, is equal to the right hand side, which is the resource, then it means that the resource has been fully utilized and the constraint is binding. So the second one is also binding because the resources have been fully utilized. The third one the same, but the last one no, because the resources have not been fully utilized. So there is a non-binding constraint here. So when we come to the shadow pricing, so this allowable increase and decrease, the same thing here. There's the maximum increase that you can have. So the range would be 70, so 50,000 minus 40,000 is 10,000. So the range is 10,000 and 10,000 and 70,000. So you can make your decision to be within this range. Then you can still have your final value intact. So I will not go there. But with the shadow pricing, it's just telling us that a 1 unit increase in the right hand side, which is the resource side, will add 45 CD to the total cost. We get it. So first of all, what is the total cost? So if you know that, let's say the cost of producing one mango is 1 CD and you produce 10 mangoes, what will be your total cost? Isn't it 10 times 1 CD, which is what 10 CDs? So in the same way, total cost here will be, since these are cost per unit, right? Total cost will be this times this time this time this time this, which we've already found here side. So these are total costs, okay? Total cost. So it's the same because I used two different formulas in my other video. All right, so this is the total cost. So this shadow price is telling us that if we increase this right hand side by 1, it's going to add 45 CD to our total cost here. If we increase it by 2, then 2 times 45 is 90. This side will increase by 90, okay? And then it means this is also telling us that if we increase here, this 70,000, even that by 1, we're going to add 40 to our total cost. And then with this side, it's telling us that if we increase here by 1, it's going to reduce total cost by 15. And this is laudable because the question told us that the company has gotten a new production line. The production line is so efficient that it enables the company to produce at lower possible cost. So it's laudable or it's reasonable to find a shadow price being negative, right? So it's very good that it's negative because it's reducing our cost. Okay, alright, our cost is 308 something something, and it's going to reduce our costs. So that's the shadow price. So for every 1 unit increase in this right hand side, the figure here is what is going to add up to the total cost. First it's a profit, then it's going to add up to total profit. So since it's cost, it means this negative is ideal because we all want to reduce our cost, right? And it's already in the question. So now let's answer some of the questions. So the first question says, what is the optimal solution and what is the total cost associated with this solution? So optimal solution is the values that give us the least objective function value because we are dealing with what? Minimum at this point. So these ones, these figures, this, and this, they are the what? The optimal solution. And then this figure is our total cost. So all you do to find it is you multiply this 30 by this 50, plus this 30 by this 50, plus this 25 by this, plus this by this. Then you get your objective function value or total cost in this case. So the next question says, which constraints are binding? So we saw that from here, the constraints binding are sandal A, because the left-hand side is equal to the right-hand side. Sandal B, because the left-hand side is equal to the right-hand side. Same for new production line, sorry. The left-hand side is equal to the right-hand side. But the old line is not included because the left-hand side is not equal to the right-hand side. The figures are the same. The figures are not the same, sorry. All right, so that's the answer. And then the next question is, the production manager noted that the only constraint with a negative shadow price value is the constraint on the capacity of the new production line. So this one, talking about this one. So the man noted that this one has a negative shadow price. Okay. So let's see what happened. All right, so Micah, sorry. The manager's interpretation of the shadow price was that 1 unit increase in the right-hand side of this constraint would actually increase total production cost by 15. Do you agree? No, because this is a negative. A negative always means decrease. So it's telling us that 1 unit increase in the right-hand side, okay, the resource side, this is the right-hand side, will decrease total production cost by 15, not increase. Would you increase the capacity for the new production? Would an increase in the capacity for the new production line be desirable? Yes, to be desirable. Why? Because we all want cost to reduce. So if we increase and it can reduce our cost, then it is recommended, right? We all agree. And the last one, okay, would you recommend increasing the capacity of production line of the old production line? So you can say that yes, because you can increase because it's not going to add up to our cost. That's one. And the other one is it's the resources, or it has not been fully utilized, for the left hand side is not equal to the right hand side. So you can increase so that the constraint will be binding. Okay. So that we have a standard form. Alright, so the production cost for standard A on the old production line is 50. How much would this cost have to change to make it worldwide to produce standard A on the old production line? So what this question is telling us that this part, standard A on the old production line, its cost per unit is 50, but then there's no value here, no product to be produced. So how much cost should it be in order for us to get a product? And we saw from our illustration that if we reduce this by this 5, which is its reduced cost, then you are going to forego some of this 50,000, 30,000, 40,000 to produce this sandals A on the old production line. So that will be the explanation. So basically that's it for interpretation of how should I put it, of linear problems, linear solution. Alright, so I'll end here today. I'm not that well, so I hope I wasn't rushing and I hope you understood. If you have any question, please leave it in the comment section. And please like the video, share, subscribe, okay, and leave something in the comment section. A thank you would do. A God bless you would do. And your own question. Okay, so God bless you. Enjoy your day. Enjoy the weekend. Thank you. Bye bye.